Okay, so solving for side lengths of right triangles. Let me share my screen. Perfect. That's not what I'm looking for. Okay. It is this one. Okay. Wonderful. Okay. So here are the words that we are going to go over today. We're going to learn the word cosine, function, sine, and tangent. Some of these words you may have seen before, you may have not, but we will go over them today. So today we're going to learn trigonometric ratios. And what a trigonometric ratio is, they are functions that take an acute angle measure as the endpoint and output a ratio of the side lengths of a right triangle. And there are three trigonometric ratios, which we're going to learn about. And they are sine, cosine, and tangent. Ooh, 1 second. Okay. Sine, cosine, and tangent. And so basically what we're going to do is we're going to be able to identify side lengths using these trigonometric ratios. And so the first one that we have is sine, and that is represented as the opposite over the hypotenuse. And a way we can remember this is so, where the O represents our opposite and the H represents our hypotenuse. We also have cos, which is adjacent over hypotenuse, and we remember this by ca, where the A is our adjacent and then the H is our hypotenuse. And then we also have tan or tangent, and that is opposite over adjacent, and so we know we represent this as TOA, or this is a way to remember it. And so we're going to look at how we can use this to solve different side lengths, but the way to remember this, or a way for you to remember this, is to use SO, CA, TOA. Where SO lets you know you have sine opposite hypotenuse, CA lets you know you have cosine adjacent hypotenuse, TOA lets you know that you have tangent opposite adjacent. And so we're going to look at this a little further. So what does this even look like? Well, basically it says here that we are going to input an acute angle and get an output of side lengths. So here we have a right triangle. And let us say we are trying to find the side lengths of these right triangles. Well, the way we would do that is we need to input an acute angle. We can use acute angle A or acute angle B. For this example, I'm going to use acute angle B. And so what this means is I'm going to input my acute angle. So I'm going to have sine B, cos B, and tan B. So I've inputted that acute angle. And what this is going to let me identify is the ratios of the different side lengths. So, like I said before, sine we represent as so, cos, ca, and tan, TOA. And so what is this going to look like? Well, for sine, we know we have to have the opposite and then the hypotenuse. So what is the opposite of angle B? Well, we know that opposites of angles are the one on the opposite side. So AC would be our opposite. What is our hypotenuse? So we always know, or what we learned is our hypotenuse is always opposite the right angle. So our hypotenuse would be A, B. For cos, we've already identified as our hypotenuse as AB, so we could put that in. But what is our adjacent? Well, our adjacent is that which is adjacent to our angle B, that which is right next to angle B. And so BC would be our side adjacent to angle B, so we would have BC. And then you could just plug it in here. Have we identified our opposite of B? Yes, we have, as AC. And have we identified our adjacent of angle B? We have as BC. And so that's how we would use the trigonometric ratios to find the relationships between our side lengths. And so this is just how we would outline it, but we can actually put variables and certain units on each of these side lengths to further identify the relationship, which we're going to get into. But the gist of what we're doing now is we know that we have to input a certain acute angle. And so in this instance, we inputted acute angle B. And then we went ahead and identified what our relationship was based on what we know about sine, cos, and tan. Okay. So now let's actually use this information to find a missing side length. So we're going to write a trigonometric ratio to determine the side length. So determine the length of line segment AC. Okay, so we're looking for the measure of side length AC. 1 second. We're looking for the angle measure of that side length. And so what we want to do is we want to input a specific acute angle, and I'm going to use this one right here. And so when I input this acute angle, angle B, I want to identify what I am given. And it looks like I am given, I'll put what I'm given in green. I'm given the hypotenuse, right? And what I'm looking for is the side which is opposite my acute angle, right? This is the side which is opposite my acute angle. So basically what I've been given is my hypotenuse and my opposite. Well, because I've been given my hypotenuse and my opposite, I want to identify whether I can use SO, TO, or TOA. Well, I've been given my opposite and my hypotenuse, so I can use sine. I haven't been given my adjacent, or I'm not looking for my adjacent, but I haven't given hypotenuse. I am looking for my opposite, but I haven't been given my adjacent. So as you can see, the most logical thing to do would be to use the sine. Okay, so that means I'm going to do sine B is equal to opposite over hypotenuse. Opposite is x, right there. Hypotenuse is 15. And so how would I go about solving for this? Well, what I would do is I'm going to first input what is my B. My B is 38. Okay. B is 38. And so now what I'm going to do is I'm going to isolate my x because that's what I'm solving for, x. So the way I would do that is I'd multiply 15 on both sides. So that gives me 15 sine 38 equals x. Okay. And so what I need to do to solve these type of problems is I need to actually go about plugging the information into the calculator. But for the purpose of right now, we want to just create the equation we're looking for. So we are going to use this equation to solve for x. And then eventually we'll get to the part where we plug it into the calculator and solve for our missing side length. Okay, but we want to get to this step first. Okay. Okay. Oops, sorry guys. What I also want to go into is I want to discuss how we might be able to use a different type of trigonometric ratio to solve for this problem. And that is sine x is equal to cos 90 minus whatever acute angle we use, or we have cos x is equal to sine 90, whatever our missing angle is. And so let me show you what these look like. So what I'm going to use is the sine, because we just use sine, and I'm going to show you that you can also use this equation, which is equivalent to what we just used for sine x. And so what that would look like is we have sine x equals cos 90, and what acute angle did we use? Well, we use acute angle B, and so we do 98. And so we get sine x is equal to cos 52. And so what this would look like is the same thing as if we were to use this other acute angle. So if we wanted to use that other acute angle, we would use cos, which is co. And what that would look like is we would use cos 52 equals cos, so adjacent. What is adjacent to it? X. What is our hypotenuse? 15. And again, you could just go about simplifying to isolate x. And so you could also use 15 cos 52 to identify x. So this just shows you that you can either use cos if you're using the you can use sine if you're using the 38-degree acute angle as your input. Or what you can do is you can actually use cos if you're using the other acute angle, which is the 52 degrees. Either way, whenever you plugged it into the calculator, what you'll get is that it is equal to approximately 9.2. And then if I were to plug this into the calculator, I would also identify this is equal to approximately 9.2. So this just shows you that depending on whatever input you have, you can go about solving the problem based on your preference of whether you want to use sine or cos. Okay, is there any questions so far? And we'll do some more examples of this. Any questions so far? Okay, let me move on. Okay, so now we're going to go about looking at an example problem. And so this problem says, for right triangle XYZ, the known angle measures are Z is equal to 90 degrees and angle X is equal to 23 degrees. And the length of XY is equal to 26. What is the measure of angle Y? And what are the lengths of the other two sides rounded to the nearest 10? Okay, so what we want to do is first create a diagram that represents this. So we know we're looking at a right triangle. So I'm going to go ahead and draw that right triangle. Right about. Okay. Then I want to label my vertices. So I'm going to do X, Z, and Y. Okay. And I know my angle Z is equal to 90, so that's why I put it right here, because that's my 90-degree angle. And I know my angle X is equal to 23 because it tells me so right there. And so I want to find the missing angle of angle Y. Well, the way I'll go about doing that is I know that the entirety of a triangle has to equal to 180 degrees. So angle X plus angle Y plus angle Z. Sorry, guys. Angle Z has to equal to 180. Angle X is equal to 23. We are looking for angle Y. Angle Z is equal to 90. Okay, 1 second. 90 plus 23 is 113. So I want to subtract on both sides to isolate my Y to find my Y. And so thus, we know that angle Y is equal to 67 degrees. So that's how I go about solving that first part of that problem, which asks me, what is the measure of angle Y? Does anyone have any questions on how I found the measure of angle Y? Kind of a review from what we did before, right? Okay, so now I want to go ahead on to the next question. And the next question asks, what are the lengths of the other two sides? So we've been given the length already of side XY, which is 26. 1 second. 26. And so we want to find the lengths of the other two sides. Well, let's go about looking for the length of Y and Z first. So we're looking for the length of YZ. Well, what we'll identify is that YZ is an opposite, right? It is an opposite of 23. So if it is an opposite, then we're going to have to use an opposite. And we also have our hypotenuse, that which is opposite our 90-degree angle all the time. So we have an opposite and an hypotenuse. Well, what does this remind you of? It reminds you of so, which means that we're going to use our sine to find the missing angle measure of our opposite. So I'll use sine. I need to input one of my acute angles, 23, equals x over was my hypotenuse, 26. Okay. And then what I want to do is isolate my x. And so I get the equation 26 sine 23 equals x. And so this is the equation which I will reach to, which is as far as we're going right now. But if you want to know approximately how long is it, it is approximately 10.159. Okay, so therefore we found this angle, this side length. And so what we want to look for is our last side length to complete this problem. So I'm going to go ahead and do away with this information. And now we're going to look for our other side length. And so we want to identify what's the best way for us to look for our other side length, which is this one right here. And what we can see is we have here an adjacent side. So we have an A. And we still have our hypotenuse, which is opposite our right angle. So we have an H. And what does this remind you of? What should remind you of co? So C. So cos 23 equals x 26. Again, you want to isolate the x. And so we're left with 26 cos 23 equals x. So that's the equation we would leave off with. And if you want to know approximately how long is that, well, whenever we get into actually plugging into the calculator, you will see that we get to approximately 23.9331. So that would be the measure of our other side length. So our triangle would end up looking like this. And this was Oops. 67. Okay. Does anyone have any questions on how I went about solving the second part of this problem? So basically what you want to do is you want to read the problem, create your diagram, and then from your diagram, be able to identify what you have. Like we did here, we identified we had an adjacent and a hypotenuse. So the best way to go about answering this was to use K. And just remember that we have so, or we have K, or we have TOA. Okay. All right. So let's look at one more example. This one says a ski resort ski lift carries passengers from the boarding station at the bottom of the mountain to the lodge at the top of the mountain. The line of the ski lift makes a 20-degree angle, which we see represented here, with the ground at the boarding station. If the ski lodge is at approximate altitude of 3,300 meters, which we see here, above the boarding station, how long is the ski lift round to the nearest tenth of a meter? So basically what we're doing is we're looking for how long is the ski lift. So what we're actually looking for is this right here. And what we can see is that we have been given information about the opposite of our acute angle, and we're looking for the hypotenuse. So we've been given information about our opposite, and we're looking for the hypotenuse. What does this remind you of? Well, it should remind you of so, which means what we're going to do is we're going to use sine. So sine, we put our acute angle, equals, what is our opposite? And what we see here is that we have something that looks a little bit different, but we can still solve it. And the way that we're going to solve it is we're going to go about multiplying my x like we normally do. Okay. That takes us to x sine 20 equals 3,300, but I still need to isolate my x. So now what I'm going to do, I'm just going to divide by sine 20. And so what I'll get is x is equal to 3,300 divided by sine 20. And I can plug that into my calculator, which we'll get into later. And you'll find that that is approximately 9,648. Okay. Does anyone have any questions about how I found this equation right here? Any questions? Questions? So what you want to do is you want to identify your diagram. You want to identify what do I have, or what am I looking for? And what I'm looking for in this instance was the hypotenuse, but I did have my opposite of my acute, right here. And so that let me know that I could use sine. So I plugged in the information into sine, and then I need to isolate my x. So that is the process I'm doing here. And then I end up with my equation here. Okay. Here's the last example we are going to look at. This says, a water tower is 52 meters tall, and the straight line distance from the top of the water tower to the end of the shadow is at a 40-degree angle with the ground. What is the approximate length of the tower shadow? Yes. Sorry, guys. The tower shadow rounded to the nearest whole number. So I want to identify what do I have. Well, what I'm looking for is what is the approximate length of the tower shadow. So I'm looking for this right here. And so I want to see what I have compared to this acute angle. Well, what it looks like I have an opposite and I have an adjacent. So if I have an opposite and an adjacent, what does this remind you of? It should remind you of TOA. So now I'm going to use my tangent. And then I'm just going to plug in what I have. So tan, what is my acute angle input? 40. What is my opposite? 52. What is my adjacent? X, what I'm looking for. And then I need to go about isolating X. I need to further isolate my X. Which leaves me with X is equal to 52 over tan 40. And then again, all I want you to get to right now is this equation. But when I plug this into my calculator, I will identify that this is equivalent to 61.97. Okay. Does anyone have any questions about anything that we went over today? Anything we went over today? Okay, so what are the big takeaways from today? The big takeaways are we have these trigonometric ratios which can help us solve for the missing side of a right triangle. Our input's always going to be the acute angle, and what we're going to identify is the missing side length. And the way that we do that is we want to identify when we're given a problem, what information we're given and what information we're looking for. And then based on that, what we can do is if we're looking for either the opposite and we're given the hypotenuse, or we're looking for the hypotenuse and we're given the opposite, what we can use is sine. Cos would be ka, and tan would be toa. So what you really should be able to do today is memorize SOHCAHTOA toa to help us identify which would be the best ratio to use to solve for the missing side length. Okay, any questions? Okay, if there's no other questions, you guys may log off, and I'll see you tomorrow for some practice problems. Bye, guys. Bye, Joelle.